Hi everyone, welcome to this DNA online training course with lab support. I am Ratnesh, I am your trainer for this particular course and what you will get in this course? Obviously, complete end-to-end training related to DNA means what is DNA, how it is working, what are the components, how we can manage from DNA, how we can manage the wired and wireless network, how we can do the automation for DNA, then how we can integrate with ST access means how we can go and enable ST access within the DNA. So all these topics with lab you will get in this particular training. Now I have partnership with Graphy by Unacademy, and you will get all these 20-hour training videos in their platform. So once you are watching this video, you can see the description box below where you will get the link related to this course, ABC of Cisco DNA 20 hours online training course. Now, what is the benefit? Once you go and join this particular course, the benefit is this, that obviously you will get the videos, you will get all the documents used in this video, like all the PPTs, slides, PDF, lab documents, everything you will get once you go and enroll for this particular training. Not only that, you will get the automation script used in this course as well. Whatever automation I have used in one of the 2-hour session, you will get that script once you go and purchase this course. And finally, where you perform the lab tasks. So I'm going to provide you the lab for 1 month. Once you go and enroll this course, then you can email and then you will get the lab for 1 month, means whatever you will study, whatever document you follow, whatever video instruction you have followed, you want to do hands-on, right? So to do the hands-on, you will get the lab, DNA and 8 routers, virtual routers that you can go and play around with all the tasks that we are using, all the training, all the lab steps that we are using in this particular training. All right. So I hope that you will go and enroll this course and you will become very good in DNA. I will not tell that you will become expert, but you should get at least the professional level knowledge after completing this particular course. Okay, please go enroll and thanks for your enrollment. Thanks for joining. We are in day 1 and today we are going to learn basics of DNA. What I will do, after a few slides, I will log into DNA and I will walk you through the DNA dashboard. And since this is 2-hour session, so we will go and take a break after 1 hour for 10 minutes, a tea or coffee break, and then we'll come back and again we'll continue. Okay, I have already shared the agenda that what we are going to do in day 1 up to day 10. So this is going to be very much action-packed training and it will help you in your DNA journey, because you will see all of a sudden in market, you will see the demand for DNA. So let's start. Now clearly you can see that we are going to learn DNA as a non-fabric, but in day number 9 and 10, I am going to show you the DNA as a fabric as well. Fabric means that how we can go and enable the ST access features within the DNA. All right, so let's start. DNA, again, is this the new product? The answer is no. Do you know any other SDN product? Obviously, you may know, you know that in Cisco we have vManage, in ACI, in a data center we have ACI. ACI is one of the SDN product for DC. Then we have SD-WAN, vManage, and then we have DNA, Digital Network Architect something center for LAN. Nowadays, LAN is not that small. LAN is big. And in LAN, you have wired and wireless. So both you have, say you have wired LAN and you have wireless. Both the flavors you have, right? And when we are talking about wireless, now you'll see lot of company, they are directly moving to wireless because no one want to see the wire. They just want wireless network. So that is high demand for wireless network as well nowadays. Now, if you have wireless network in the infra, then security is one of the concern for wireless network. So then, can we provide security inside DNA? Now, before going there, I'm going to ask you a few questions to you, and you can unmute yourself and answer that in SDN, what type of planes we have? Any SDN.
Control plane.
So we have control plane, yeah.
Management plane.
Management, yeah.
Data plane.
Data plane, yeah. Any other?
Well, I mean, is the API plane a plane or not really?
No, it's a service like CLI and GUI.
Okay.
So perfectly fine. Control plane, data plane, management plane. But in Cisco SD-WAN, generally there is one other term is vBond. That term is an orchestration plane.
Oh,
Okay.
okay.
But in that is in we manage in Cisco SD-WAN. But you are spot on. These are the three planes we have. Actually, SDN definition itself is decoupling of data and control plane. That is the SDN. So that's cool. But one thing here new in DNA fabric actually, that in DNA, so suppose SDN related to DNAC, we have something called policy plane as well. So when we are talking about that managing the wired and wireless network with the help of DNA, that means that we are managing wireless network which is less secure or prone to be uh, less secure because we know that someone can go and connect with the APs and try to do some unnecessary things. So point here is this, that we want to secure we want to secure the wireless network. We want to provide the security to wireless network, right? So how we can do with policy plane, right? But do DNA has policy plane itself? The answer is no. DNA do not have policy plane natively. So can I go and integrate DNA with firepower or cloud-based firewall or some other thing and umbrella and this and that and that? Can we integrate? The answer is yes, we can integrate, right? Now, think about network without DNA, for example. So in your network, for wireless devices or for wireless network, how you're providing security? Who is the device who is providing security?
Usually it's the controller. The wireless controller has the security.
Wireless controller, but wireless controller has integration with which device?
The firewall.
Yeah. Well,
They have integration with ICE, right?
with ICE, yeah.
Identity services. Now, in ICE, what you can do for security?
What do you call it? Control the MAC addresses that you want to authenticate.
Yeah, generally we know this AAA, right?
Yeah.
Well,
Authentication, authorization, and accounting, right? Generally.
Right.
But do we have any other thing we can do from ICE?
Oh yeah.
Specific to wireless.
I forgot the name, but
Okay, no problem. So think about users.
yes.
LAN is all about users, right?
I think you can control the MAC address that you authenticate, right?
So we are talking about MAB authentication, okay?
Yeah.
That is one thing. There is other as well.
EPOL or
.1x, right?
yes.
Yeah, EPOL and all that, EP, PLEP, right? These things you are doing in the ICE, correct? Now think
Yeah.
like this. You have HR department, you have sales department, right? You want to provide some sort of micro segmentation or macro segmentation, whatever we can tell her. This is actually macro segmentation. So two different groups. Can you go and provide some security in between two groups?
In ICE?
Yeah,
Yes, you
in
can put them
ICE, yeah.
Well, you can have
VLAN based, right? Like
VLAN based
groups. Yeah, you can have
groups.
groups in
We have
ICE.
groups,
Yeah.
yeah. That's right. What that group's term? What is the name of that group?
Oh, geez.
Something called a scalable group,
Oh, scalable groups.
right? Now, what's the use of this scalable group? That we are putting some sort of tag. So for example, we have employee having tag 10. We have, for example, we have HR having tag 15. So employee and HR. Then we can go and create some sort of contract in between them that they want the traffic is permit or deny in between different groups. The term is itself called as SG ACL.
Well,
SG
it's like an
ACL.
access list, right?
Yeah, it's like access list. Yeah, SG ACL, security group access control list that we can provide. So point here is this, that when we are talking about the LAN network, right? Local area network. And in that LAN network, you have wired and wireless devices, correct? Now, both the wired and wireless devices, you can go and provide security with 8021X and MAB, because the MAB, MAC address bypass, and .1X, these features are there for both wired and wireless network. There's no problem on that, right? You can go and create policy inside ICE. You can tell
Sure.
ICE, okay, if this is the condition, do this. This is the condition, do this. This is the condition, do this, right? That means ICE is working as a identity services. ICE is working as a brain in the network, but you can go and integrate the ICE with DNA. So that means DNA will take primary role, right? And whatever configuration we will do in the DNA, it will get replicated within the ICE. So that means that somehow ICE and DNA, they are doing the communication. Now, how they are doing the communication, do you know? DNAC and ICE, how they are communicating. What is the communication channel between ICE and DNA? You have something called Pixie Grid. It's complete API based service behind the scene, complete automation. We have something called Pixie Grid services that you have to go check mark in the ICE. Once you do that, once you do the integration in between DNA and ICE, then whatever things, so this will become your primary. So whatever policy, scalable group, virtual network you will go and create in DNA, it will get replicated in the ICE. Okay, and from ICE, from DNA, you can manage everything. But as you mentioned, that there are different type of control management and other planes. So as you mentioned that we have, let me change the color. We have management plane, control plane, data plane, and I have added one more, that is the policy plane. So management plane you have control plane, you have data plane, and then I have added policy plane. So policy plane is nothing but the ICE. Data plane, what is the data plane in DNA? Let's go one step ahead now. What's the data plane we have in DNA? Data plane, right? The router switches where actual data is moving. Router switches, APs, they are nothing but the data plane devices, right? What's the control plane? At the moment, we are using this ICE as a non-fabric. For example, in the fabric case, I will tell you that the border and control devices are the control plane and all. We'll see that later on. At the moment, for non-fabric, this is non-fabric. We have router and switches, their intelligence, APs and controllers. Not AP actually, controller, router, switch. Because router, switch, you have control plane, data plane, management plane, everything in it. If you are not using as a SDN. So control plane will be your router, switch, and the controllers, WLC controllers. What is the management plane? The DNAC itself is your management plane. And policy plane will be ICE. Any doubt in this?
No, makes sense.
All right, great.
Well, the policy plane is ICE.
Policy plane is ICE, yeah, because where you are creating the policy for network. In ICE, yeah, in ICE only, because ICE is actually one of the nice product from Cisco, which is one of the most sold identity engines we have in the network. Even different companies, they are using different products, but they are using ICE as a identity services, right? All right, so what we want to do in day 0 or day 1 is that we want to know the steps that how we can go and install the DNA. DNA is actually completely Linux based service, but DNA is big. Suppose we'll go and see the hardware related to DNA. It's a big server. In that server, not only that we have, suppose run any Ubuntu machine. And in that Ubuntu, you can go and enable different type of services like IP tools, firewall, and etc., etc., etc. DNA itself, its operating system is maglev. Actually, grapevine is the operating system. Let me write here because I think this is not mentioned here in anywhere in the slide. Grapevine. Grape, I think wine, or you can check the spelling, V-I-N-E.
Grapevine
So,
or grapevine?
grapevine or wine, I'm not sure, but you can check. It's a V-I-N-E or W. So here I have some confusion. Anyway, grapevine or grapevine. Actually, grapevine. This may be the correct, I think, because it makes sense. Anyway, so this operating system name is this grapevine, but behind the scene, very much if you go and check their the architecture, and obviously we'll discuss about the architecture in the next class, means tomorrow. I'll show you a few of the slides related to architecture. If you see the architecture, you'll find that it's very much inspired from Kubernetes. So if someone knows Kubernetes, if you know that container, you know at least 80% of the CLI commands in the DNA. We know in Kubernetes we have something like kubectl. Here
Yeah.
you have something called maglev, is the operating system for the containers. But here you have something magctl. But either it's a kubectl or magctl, the commands are almost same.
Hmm.
So that's one thing. This behind the scene, its service is containerized. And later on, I will show you some other things as well that will make sense related to this operating system. And Cisco is using so many open sources, and then they have converted those open sources as an enterprise software. So maybe you know about different type of open sources like Elasticsearch operating systems. Then you may know about there are graphic tools and others, and like Kibana and MongoDB and all those things. Like if you have any exposure on cloud, do anyone know cloud and services and all, like AWS or GCP or any other services, you know about that?
Yeah, Azure.
Okay, so Michael know about that cloud. Henry, you know about cloud?
Some AWS.
AWS, little bit, just the basic fundamental, yeah. Okay, so like cloud, right? In cloud, you have different services. Like for a storage, you have something, right?
Yeah.
For load balancing, you have something. For database, you have something. For DBMS, you have something, right? For authentication services, you have something. For compute, you have something like that. When we'll go and check the hardware structure of this DNA, you will find that for database we have MongoDB. For searching, we have Elasticsearch. To represent the graph, we have Grafana. You know, like that. For big data, there is something like that. We have all those things within the hardware itself. We'll see that, and that's the thing we have in DNA. Means, see, our mindset should change now. So now we should not think network as a network. We are thinking, okay, network means what? Collections of router and switches. That's it. But here the thing, we should see that, oh, network, how many traffic is coming, going, network, how many services I am using in the network. Think network as a subscription. If a network, how I can abstract that network, and then how I can do the virtualization for the network and all those things. All this mindset will change, and that's the mindset that Cisco has, and then they have created the product DNA. So they are not thinking network just as a network. They are thinking network as some sort of service, as some sort of software. So suppose from this network, I want to know that in last 10 days, how many bandwidth and the utilization, peak utilization. In this network, in last 20 days, how many applications having peak utilization? In this network, in last 30 days, how many routers are down? These are the questions, right? These are the questions that someone can ask you. Now, these questions, if you think these questions are not the questions, but these are the query, for example, you think that these are the query, right? And when you are doing the query, where you are doing the query? You are doing the query to the database.
Yeah, you got to do it on each individual. Yeah, right.
Yeah. Right. So now, if you have this information in the database, then only you can query and you can get the response. And the best thing to do the query is actually the API. Even we are not using the API, so what we are doing? We are thinking, okay, I log into DNA, right? And in DNA, I am running some GUI options, right? I am doing something from GUI. Behind the scene, the GUI, they are converted in the API and then we are getting the result.
Right.
Earlier in days, the GUI was converted in CLI and we are getting the output. But nowadays, the GUI, they are converting in APIs and we are getting the output.
Right. The API calls.
The API calls behind the scene. That's the shift we have in a network. We are in the next generation network where network itself has its own database. And since network has a database, so we can query and we can get the response, right? So that's the cool thing we have. You will see that the DNA has the database. That's why we can query and we can get the response. Now the upcoming slides, you'll find it very easy knowing this much information. So future of network, some slides taken from Cisco. And you can see that it's actually the fact. So we know that in network, the data center, WAN, core, distribution, access, everything is there. Users, and now we are using so in between you have network and the user. Why user will think that they have server somewhere in DC and there you have some application and you want this application. So that's actually the end goal. For a user, why they will think my traffic is going via the firewall and this and that and reaching to the server from where I'm getting the response. For
No, the
user,
user.
like, yeah, for user, they may think that they are a web user, right? Application user. Yeah, you're telling something.
Yeah, I'm saying, yeah, the user doesn't care how it's getting, where it's going.
Yeah. So behind the scene, what a story is
That it
that or not?
works. Right.
Yeah. So just abstract everything in somewhere and then they will send some request and they are waiting for some response. And nowadays, even things are getting worse because of this AI evolution and chat, GTP and other things. So in future, you have to study those things as well. Even if you not use those services, but still you have to study those things. Even nowadays, I'm using chat GTP Chrome plugin. So generally what we are doing, simply we are going to Google and we are asking Google, okay, Google, tell me this. But I want some accurate information. So I'm going to chat GTP and then I'm typing that query and I'm getting the response. This is just one small use case. Think about big companies. I know a few of the companies and it seems very funny, but they have fired maybe thousands of customer service, desk employees who are the who are the prime contact. Someone was calling to the help desk and they are responding. They have fired. Why? Because using this chat GTP and all, they have integrated their help desk with chat GTP. So chat GTP they can give better response than the humans. You know, these things are happening and it will happen. But the point here is this, that whatever, because we are the intelligent devices, humans. So if new thing will come, we have to go and learn and use it. Right. Even in DNA also, you will see that we have integration with AI. DNA will go and you will find it's very interesting. DNA will tell you what's the issue, what's the root cause, what's the solution, where is the issue, when it happened. Everything DNA will, not only it will tell you, but it will give you the picture as well. See, this is the issue, like that. So these things are there. We'll see later on.
Wow.
Okay. All right. So you can see now the basic thing, like the traditional network, difficult to segment, complex to manage. Main thing is the resolution. Now in DNA, you can see everything, the topology, the issue, the breakage, the link down. So since you can see that, you can click to that device and then it will tell you. Even DNA will tell you that this is the issue and these are the CLI commands. Run these CLI commands. And and if you are using
Can
those,
do your thinking for you. You don't have to think anymore, huh?
yeah. And if doing those CLI commands, if issue is not resolving, then the last option is that the reach out tag, like the DNA will tell you. And again, this DNA you can integrate with ticketing tool like ITSM or any other. So these information automatically can be replicated as a ticket in the ticketing tool like P1, P2, P3. Once DNA will send this information to the ticketing tool, they will tell, okay, this is the issue and these are the CLI commands you can check. And even if you are able, you are doing these commands and you are unable to resolve, then reach out to TAC. So at the moment the P1, P2 tickets will come, obviously, and again you can integrate with PagerDuty, WebEx, Teams, blah blah. All those integration option is there. If any P1 ticket is there, it will reflect in those channels as well. So anyone in that group will come to know, oh, this is the issue and this is the solution. We should try it. So those things are there. That's why this issue, a slower issue resolution. So because in the traditional network, if issue is there, then client is waiting for 2 hours. Oh, maybe it will get auto resolve. After 2 hours, they are sending the mail to the help desk. Now help desk, they are doing ping and trace route and all, and they are waiting for 2 hours. Then they are sending this to L1 engineers. The L1 engineers, because help desk, they are promoted to L1. So they are also doing ping and trace and all those things. And then they are sending that ticket after maybe 2 hours to the L2 or L3 or any other team. Now these L2, L3 engineers, they are very busy guys. So they are working on multiple tickets and all, then they don't have time to look. So they are waiting for 3, 4, 10 hours to this ticket gets, escalated, or maybe good chances there they will go and directly go and resolve it. But the point here is this: they don't know which area, which router, which switch. So they have to go and check their share folder or drive and all, or whoever working in that location, call them, check. So it is taking 3 to 4 hours here as well, just to know what is the issue. So overall, you can see that 10 to 12 hours, it is completely wasted just to know that which customer is affected and what is the issue. Now this will be saved because at the moment issue is there, it will trigger in ITSM. If it is triggered in ITSM as a P1 or P2, we know that we have SLA fixed. For P1, you have to respond in 10 minutes. If you do not respond, then it will breach the SLA, and the engineer in that particular ITSM group, they are answerable. They have to give the justification why they have not checked that P1. Right? Now, once they go and open this ITSM button, they will know what's the issue, what's the site, and what's the problem, what 4 steps we have to check, because DNA will suggest those things. If they are able to resolve, well and good. Otherwise, they will go and resolve it. But anyways, this 10 to 12 hour will saved. Now, 10 to 12 hour for one ticket may cost some rupees, maybe $100, for example. And it depends upon issue to issue. Some issues are very critical, some issues are less critical. For example, $100. Now, in a month, so suppose in
That's
a
one,
day,
yeah, that's one ticket, right? So it
yeah,
multiplies.
yeah, and suppose if we have 1,000 of hours, so you can see how many dollar is getting wasted
Wow.
for 1 month. So it's a big saving actually behind the scene. If we have intelligent device like DNA and we are using all the capabilities and features in DNA, it's a huge saving, money saving
It
using
pays for
DNA.
itself
Yeah,
practically.
yeah.
Yeah.
So it's nice because the issue resolution is really faster, and you have seen the dashboard, right? So let me quickly go to the DNA dashboard. So I can justify this. Actually, it is easy to manage. So if you go to DNA, you can see how clean this dashboard. Now, once we'll go and discover the devices, you'll find it will tell you in the dashboard itself, it will tell you how many P1, how many P2, what is the health of router, what is the health of switch like wired and wireless client, how many sites device. In the dashboard itself, it will tell you the issues and all those things. And if you click here, it will go directly to assurance engine, and nice chart and graphs are there. You can see the 40 hours, or if you have sites, you can go and filter the sites here. I will see all those information. 24-hour, you can go and check 3-hour issues, 7 days issues. It will tell you all P1, P2, P3 AI driven. See this AI, artificial intelligence driven issues. Right. So now you have a tool which is AI integrated. Right. So it's actually faster. You log into DNA, you can see this dashboard itself is very fast. I'm clicking and I'm reaching to that place. It's very fast because I don't know what type of interface is this. Maybe Java, but very lightweight Java is this. You are clicking here and you are going into that. It's very fast behind the scene. You know, unlike I used SD-WAN vManagers as well. And Cisco is making vManage to look like this only. So if you see the newer version of vManage and the older version of vManage, you'll find the difference. So behind the scene, even the ICE also Cisco is making like this. In ICE also in 3.1 or 2, you will see such type of dashboard and menu and all. The Cisco is trying to make everything look like DNA.
Hmm.
All right, so yeah, we have all these features, and you have now DNA, and DNA, one of the term used for DNA is, and that's really good, that's intent-based networking. DNA is using intent-based networking. What does it mean? Okay, you know what is meaning of intent?
Yeah.
Yeah, tell me that.
Well, it's designed to deliver a certain result.
Certain result, right? So we can say that we have now business intent based networking, because with DNA we are serving some business models or some business. So you can see here clearly in the diagram that business has the goal, right? And then that goal we try to achieve with help of DNA and DNA services. Now here you can see the DNA architecture in you can see the high level diagram of DNA architecture. It's not the low level diagram. So you can see that DNA can do automation, DNA can do analytics. We have something called assurance engine to do all the analytics thing. Can DNA do virtualization?
It says it
Is it
can.
is it possible to do virtualization? And it's not like a VMware type of virtualization, right? So we'll see that how DNA can do virtualization. And then you have the devices which is DNA ready. So what does it mean that devices are DNA ready? And then DNA can have some integration with cloud and all to upgrade the DNA images and all. So the thing here you can see that this is the DNA box itself. And DNA box, they are fully supported the container concept. So that means that inside DNA, you can go and you have the containers, you can go and run any application within the DNA. And that's why it is telling you the virtualization, because this architecture is very much similar to Kubernetes architecture. And we'll see that later on. Okay, and DNA can do automation, analytic, and cloud services are integrated. But what does it mean by the DNA ready physical and virtual infra?
I would assume that means you have to have Cisco devices.
That may be one good point here, that Cisco devices, but DNA is supporting non-Cisco devices as well. So DNA is supporting Juniper, Dell, any number of devices, but they are not doing full-fledged support, like 100% support that they can do with Cisco devices. But you can discover any device in DNA and you can see in the inventory. As long as those devices understand SNMP, you can discover those devices in DNA, non-Cisco devices as well, and it will show you that. And DNA nowadays, they are adding more and more features to manage non-Cisco devices as well.
Yeah,
Okay,
because I mean, I have been in companies where we've had, Cisco infrastructure, but the wireless was a different company, So yeah.
Aruba or maybe some other. So yeah, you can discover those devices in DNA. DNA can discover, and one goal we have with DNA is that DNA can work as a source of truth. That means that you can discover all the networking devices within the DNA, and then if you have to trust some inventory, you can trust the DNA inventory. So it can work as a SOT for all the networking devices we have in the infra. Now again, we'll see that is there any prerequisite to discover the devices, and DNA can do full-fledged support for those devices? Yes, you should enable the netconf on the devices. So then DNA can give you full-fledged services like license discovery, like telemetry and other application visibility and all. So we should go and enable the netconf within the device. All right, I told you that I'll give you break after 1 hour. So we have good amount of theoretical slides, and I will go through 2 or 3 theoretical slides, and then we are going to perform a lab as well. The same lab you can also perform once you get the lab credential. Yes, so Cisco DNA is an intelligent platform. It can learn the context from the eyes and can take action. It has intent-based networking driven by knowledge. That means that not simply that we have to go and do the configuration for router and switches, but we have to go and do the planning. So you can see that different phases we have in DNA now, that we have to go and design the networks. Before even doing the actual provisioning, we should go and write it down everything that what we want. What is the site? What is the design? What is the pool? What is the pool IP? What's the global IP addresses for different servers? All those information we can go and plan in the design section. We can do the configuration, and then we can go to the provisioning and do the actual deployment. Right. Once we do the actual deployment, then we can go to the assurance section and we can see that what is the status of those devices. So that's why you can see this provisioning, design, and assurance. Now, if we have integration with policy plane, that is ICE, then we can go and create different type of policies. We can do end-to-end segmentation and traffic filtering in between different groups. We can achieve with the policy section. So those things we can do. Now today I'm going to give you one small lab task that we want to design. We want to design the site. We'll go and create site, and then we'll go and discover few of the devices, and those devices will go and assign to the site. That very small task we want to do today. And this particular task will give you a little bit of hands-on and the interaction with the DNA. All right. So let's do this together. Now, once you log into the lab that we have the AnyConnect, and if I get to the secure CRT, let me go there. I have all the devices management IP in my secure CRT as well under DNA lab. Let me quickly check the devices they are accessible. Yeah.
You can export that to us, right?
Yeah, you can. You can make all those things like this that I have created the lab. You can also create the same, right?
He's saying, can
I
you have
just
your
wanted to see the SNMP string. So while discovering, we should know the SNMP community. Here you can see if I go up arrow.
Yep.
And I'll do one thing. Cisco RO. RW. Okay,
Which are
so yeah,
the new one?
just rewrite community, just put that. Even you can go and put SNMP version 3 as well with encryption, all those parameters. And generally that is recommended to use SNMP v3. In this lab, I'm just using this v2 with the same community. So now what we want to do here is this, that we should go and this, yeah. Yes, Henry, you're telling something?
Yeah. Do you need the enable traps for all these?
No, no,
can
it's
you?
not required. Just the SNMP string, that's it.
Okay, but I mean, is there one command that would, I mean, or for each and every service that you want traps for, do you need to
No,
say
we don't need any of these. It's by
okay,
default there in this lab.
is there already? Okay.
Yeah, we don't need any trap, anything. We just need this SNMP community string. And if we are running version 3, then we need version 3 information. That's it. So I have these IPs 198.168.200 up to 207. Let's try to go and discover these devices. But before discovering, I want to create the sites as well. So what you can do, oops. What you can do here, let's go back to the session.
The recording?
Yeah, it's just going on, yeah.
Okay.
Let's go here, oops, DNA. And you can see, you can go to the menu, go to design, network hierarchy. And now in the global, you can see area and all. You can see in that I have one already created called Phoenix and some dog park floor 1. But let me show you how we can create ours. So I can go and add this new area.
Now you're
And
adding an area to the global, right? What the
yeah,
thing at the top
within the
says
global,
add
yeah.
site. What is that at the top where it says add
Yeah, that's
site?
the same thing, yeah. From here also you can go and add.
Ah, okay.
From here also you can go and add. And now
Yeah.
suppose if you are importing these informations from Cisco Prime. So Cisco Prime you can go and export, and then you can see this import button here. So you can import those information as well. Import site, maps, and bulk AP,
Mhm.
right? Even you can export from here as well, but we can import from Cisco Prime and we can put here as well. So all sorts of options we have. And then you can see that different view options we have. If you go and click to list view, it will show you like this. Then you have this summary. It will show you like this. You know, it's actually very good. We'll see all these options slowly. So now let's go here to the global, because I want to create anything within the global. So let's do this. For example, I can go to global and I'll give USA. Generally, the businesses, they have business in Asia, means APAC, Europe, USA, like that. They can go and define the region. So once you go and click add, and just for sake of simplicity, I'll go and create branch 1 and branch 2 here. That's it. I'll not go and give the sub-regions like in within US. Obviously, there are different states like, uh, New York, California, etc. Means there are so many. So now you can see here that we have option called add area or add building. Right. So if I go and add area again, so it is asking that what area name you have. Just for knowing this thing, I'll go and add NY, New York, and add here. So now you will see what will happen, that inside the US, we have this NY. Like that in US, we can go and add all those states, right? Suppose I have this NY. Now in this, I want to add two branch. Suppose I have branch 1 and branch 2. You can go and give the address and exact information about the latitude and longitude. If I click add here, it is throwing error. It is asking that give me the specific latitude and longitude. So let's give some random number here just for our lab practice. Add somewhere in this region. And then I'll go and add one more branch 2 this time.
I was hoping that once you put the address, it would know the
Yeah,
coordinates.
that's not the right New York range. Yeah.
Yeah, means I don't know, sorry for that, but I'm just putting any random number here.
No, I know. I'm saying it's not smart enough to know that's not in New York. It should know that. So that's
Okay.
not New York. That's
Okay,
okay.
so you can see these regions that it is telling, and then we have branch 1 and branch 2 here. Now in these branches, we can go and add the floor. So now
Oh,
we are inside the area, and then we have inside area, we are inside the building, and within the building, we can go and add the floor. So let's add one, just to show you, I'm adding one floor. And in this floor, you can import the floor map and all those things. So I can go and give the name as, for example, floor 1. And then you have this upload file option. You can upload. Moment I don't have, so I will go simply and add without any image. Yes. So now you can see this, some default image will come. And we are inside floor 1, where we can go and map the APs. If we have proper floor planning, we can go and discover the AP and we can map it. And even you can see that we have nowadays 3D view as well. Later on, obviously, we'll go and see these features. I will show you this nice 3D preview of that particular floor. It will tell you. Okay, so at the moment, your task is this, that you go to the global, create USA, and inside that any state, and then branch 1 and branch 2. So this is related to site hierarchy. Like that, we can grow our site even before doing any networking thing. We can grow and we can go and do the designing. This is the planning part. We can go and plan, right? Now, next thing here is this, that discover the devices and assign to these branches. So let's do one thing. Let's discover router 1 to 4 and assign to branch 1, router 5 to 8 assign to branch 2. So let's go there. You have multiple options. You can go to the DNA dashboard here, and if you scroll down, you will find somewhere that you have discovery, or you can go to the menu. You can see here that you have in the menu, you have something called tools. You can click to the tool section. And once you are inside the tool, then it will tell you the discovery page. It seems that it got a little bit hanged. Maybe some network issue, but it will come. Generally, if something will happen like this, that means some any connect issue. You can go to the tools and then you can see discovery, click discovery. Once we are inside the discovery, the page is popping up. I think one of the router is already discovered. Yeah, no problem. We can go and click this add discovery. And this discovery name, class 1, day 1, whatever. We'll give the logical name here and then CDP IP address LLDP. We'll go and give the IP address range. We know that IP address range is starting from 198.1.8, that is my management IP, 201 up to, oops, let me copy and paste, 208. So this is the range we have. And then you will see the credentials. Now you may think that how these credentials are coming here, right? We'll see this part as well. I will show you that. But in case in this page itself, if you want to add, here you have this button called add credentials. You can click this and then you can go and add the credentials. So already the CLI is there, then SNMP read is there, some lab SNMP something. I'll go and give right as well. Go and give lab SNMP Cisco, but this we haven't specified on the other routers. Okay, so I will save it just to show you, but I will not use this. I'll show you how to disable this, and then we should go to netconf. Port number is 830. Save this as a global setting, save it. And then you will see that the netconf will come here. And if I click here advanced, you will see that we have SSH enable by default. Now what I want here, because this SNMP configuration for write, I haven't configured on all the devices, so I will disable this. We have lab credential CLI and SNMP read, that's okay. And then we can click discover. You want to discover now, later. You want to discover only new devices, which is already not there in the list. I want to discover everything. Now I clicked here, you can see this task has been scheduled. Later on, I'll go to this task area and I will show you all those information related to task, how it is scheduled and all. Now behind the scene, the DNA start looking for all those devices. And now if you go to any of the device, and if you go and check the users, you will see that DNA logged in. This is the DNA IP to this device, log into this device because it is searching that particular device. It will log in, do the SSH, discover, and that entry you will see here in the dashboard. So now you can see 7 devices successfully discovered. The status, the SNMP, the CLI, the netconf, all these are green, 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 green. That means we are very good. But If you go here to the menu, provisioning, inventory, although DNA has discovered all those devices, but they will be part of unassigned devices. Why? Because these devices has been discovered. They haven't assigned to the proper sites. Correct? So if I go and refresh the page, now you can see all the name of the devices. You're not seeing router 1 because it is already assigned somewhere. So what we want to assign 2, 3, and 4, for example, to USA NY branch 1. So you can select these devices like this, these 3. You can go to the action on the top. We have option. We can go and use this inventory, edit the device, or better option is this, go to provision and assign device to site. So go here and then choose the site, which site you want to assign the device. I want to go to this branch 1, save, and then all the devices, also the rest of the devices, I want to assign to the same site. Now this is very interesting, this page. You'll see the workflow. The following settings has been seen. For that particular device, R2, R3, R4, the SNMP trap server is DNA. The syslog is DNA. The net flow is not configured. It's not configured. The syslog label is 6. The controller certificate, yes. Isn't all these informations, they are telemetry information, right? So that means that by default, the DNA is our telemetry server, and it should be. So DNA can have all the assurance data. DNA can calculate all this telemetry information, and then it will present all those data inside the assurance page, right? Click next. Now, DNA has added one new feature in DNA in the recent version, that generate a configuration preview. Now, the thing that we are doing is called provisioning. Later on, we will see that provisioning, in the provisioning, we can go and add some configuration as well. And at that time, if you want to generate the configuration preview, it will show you the CLI configuration before pushing to the device. At the moment, I'll not go to this. We'll see later on. Assign. Now, once you assign, that means these 3 devices will be shifted from the global to the branch 1. It will take some time, 1 to 2 minutes, no worries, because DNA is logging to the devices and doing all those things behind the scene. Now, once this task is get completed, again we'll go to inventory, and the rest of the devices I will go and search within the branch 2. It seems like it's stopped here, but no problem. We'll go and refresh the page. It seems that DNA is getting stuck. Anyways, it will come back. So now I am not seeing this, and that means that is discovered within the DNA. Let's go back to DNA. Oops. Oops. Let's go back to menu, and so if we go back to provisioning and inventory, we will see that within the USA and this and branch 1, all those 3 devices. And on top, you can see one notification. It is telling to provision subscription, this subscription for telemetry. You must enable this device discovery with netconf protocol that we have already done. We have done this, right? So now you can see that these devices are here. Very nice, easy. There are different things that we can go and check, like compliance and all. Later on, we'll see it's very cool features we have related to compliance and all. Let me quickly do one thing. Let's go back here and quickly assign rest of the devices to branch 2. It will not take much time. It will be faster. Branch 2. Apply to all. Next, next, next. I will show you all this configuration, advanced configuration and all those things. And apply. Simply what we have done so far in this activity, we have created certain devices, and those those sites that we have created some sites and hierarchy in the design section, and we have discovered few of the devices, that is activity 2, and these devices we are assigning to those sites, right? So it's done actually. Now if you go here and check the branch number 2, so you will see that within branch number 2, these 3 devices discovered. Now, if you go back to the design and the network hierarchy and the branch 1 or branch 2, okay, and here, and here, and if you come down here, so one thing I just wanted to make you note here, it's very important thing, and later on we'll discuss about this thing, that once you are here in the global, so you can go to global. Let me show you this from network setting, you'll understand what I'm trying to tell. So once you are in the design section, that means that you are designing all the global parameters. If you go and do the configuration, all this configuration in the global, right, and save it, save button is there, that means this global configuration will be abstracted or inherited to all the sites that we have below. You can see this inheritance settings. So that means if I go here and add a DHCP server, just an example, say 10.10.10.1. If I go and save this, that means that this DHCP server information should be on all the branches or sites below it, right? That is huge time saving, because later on you can go and add the AAA information, ICE information, for example, here, the network and the client endpoints, etc., etc. You save to the global, and automatically it will push to all the sites. But in that case, only one thing you have to do, that you have to reprovision the devices. That's it. Okay. Again, I will come to this point later on. So what we have done, we have created so we are inside the design section. We have created this network hierarchy. Once we have the network hierarchy, I think I have to refresh the page. Once we have the network hierarchy, then we can go discover the devices, and then all the devices will be shown there. So you can go to the provisioning, actually you can go to the tools and discover. Once you do that, then you can go to provisioning and inventory, and then you can assign those devices to those particular sites, right? Any doubts so far? Right. So there are so many new cool features we have. Here you can see this topology option. It will go and generate the topology for us. And oops, I can shift a little bit up. It will generate the topology for us, and then you can see that we have filters on the top where we can go and add some more information, tagging or routing or VLANs, if we have those things. Just example, I'm showing you like this. And then we have this location option as well. Now later on, I will show you that you can see these devices, they are showing this green color, right? If you simply click this device, the summary page will come. It will tell you about the device detail. You know any other platform that is like this? I haven't seen this type of reverse platform present in networking. It's
I
telling about,
know
yeah,
Arista Cloud Vision Portal
yeah,
is
that is also very good. Yeah, Arista
is-
Cloud. Yeah, that is also good. And from there, you can do lots of automation as well.
yeah.
Advisories, but generally Arista we are using for data centers, right? And that
Uh,
is one of the, actually that is really good. I have seen that platform. You can do automation on go, like dynamic automation from there. That's really
yes.
good. And there are other as well. The other in terms of like NetBrain and you know um what other? One is NetBrain. Maybe you heard about Glueware.
Mm,
Glueware is there. Then um IP Fabric, like different platforms are there, but they are completely orchestration platform. It's not like very much deeply integrated like DNA. DNA is deeply integrated, so those platform they can discover the devices and then you can run some automation from there, but you can't do whatever we are doing, all sort of things like assurance, advisories, discovering, health monitoring, ticketing integrations, like so many things within same. And finally, you have this SD access capabilities and all. And once you are here, then you have this view 360 run command. So from here, you can go to the CLI as well, CLI prompt of that device as well. So now we are here in the CLI prompt and we can run show IP. Any CLI read commands we can go and run and we can get the information. Even we have the health monitoring like view 360. So those options as well. Anyways, these things will come later on when we'll go and study more about this product. I will explain this later on. All right. So far, if you have any question, please feel free to ask.